Hey everyone, welcome to section 2.1.7, and today we're looking at sequences versus functions, round one. All right, so we're going to basically see what is the difference between a sequence and a function. So on the front here of this page, we see this sequence -5, -1, 3, and 7. So notice we have a blank table here. So what we're going to do is put our values in here. So this would be the n. Remember, our inputs are n's for sequences. And then our output would be t of n. Think about what value we always start our sequence tables with. That would be 0. So we'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we can see that our pattern is +4. Remember, this is term number 1. So this would be 1, 2, 3, 4. We have to work backwards to get to term 0. So if we're adding 4 going to the right, we'd have to subtract 4 going to the left. So we would be at -9. So our 0 term is -9. First term is -1 because that's the first number we originally saw. Second number is -1, 3, 7, 11, 15, 19, 23, and 27. All right, so what would our equation be for this table and this sequence? Well, since it is arithmetic, we're adding or subtracting. Remember, it's going to be in the y equals mx plus b form. But since it's a sequence, instead of x, we're using n. Instead of t of y, we use t of n. And our slope is what we're adding or subtracting, or the change in y over change in x. So our change in the output is 4. We're adding 4. And here we're adding 1. So our slope, or our common difference, would be 4. What we're adding or subtracting. In this case, we're adding 4. And remember, our y-intercept is always next to the input of 0. So that's why we go back to get that 0 term. So that would be -9. All right, then the question asks, can t of n equal 400? So what we're doing is we're replacing the t of n, the left side, with a 400. And we're trying to solve for n. So here, I would add 9 and get 409 equals 4n. And when we divide by 4, 409 divided by 4 is 102.25. Well, can sequences have decimal n values, as decimal term numbers? And again, that answer is always no, because that's when we have sequences, the term numbers have to be whole numbers, like term 1, term 2, term 3. Like this is term 1. This is term 1, -5 is term 1, -1 is term 2, -3 is term 3, 7 is term 4. There is no such thing as term 1.5 or term 102.25. There's no such thing. So it would skip over 400. So we're going to say no. The sequence does not include 400. And again, the reason, because n is a decimal. As we go to graph this, we're just plotting the points from the table. There is one big difference about sequences, though, which we'll get to in a second. So if I plot all my points, and I'm just looking at the table that I have above here to answer this plot the points. Now, the big question is, do you connect the points? Remember, in sequences, we cannot have decimal term numbers. There's no inputs that are decimals, so therefore we should not be connecting the points. If we connected them, that's saying we could have an input of 2.5. So we are not connecting, so this would be a discrete graph. As you flip to the next page, now we have a function. F of x equals 4x minus 9. So if you notice, it's the same basic equation as the other side, but now it's a function instead of a sequence. So if we plug 400 in for f of x now, and we solve for x, and I would then have 409 divided by 4. And in this case, again, we have x now equals 102.25. Well, can a function have a decimal input? And of course, that answer is yes, because we can have decimal inputs, decimal x values for functions. So this would be yes. Functions can have decimal inputs. As we go to our table, remember on the other side we had n and t of n, but now it's a function, so we'd have x and f of x. And on a function, we can have negative x values as well. So I'm going to go -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And so if we just plug in numbers here to start, if I plug 0 in, 4 times 0 is 0, minus 9 is -9. If I plug 1 in, 4 times 1 is 4, minus 9. 4 minus 9 is -5. If I plug 2 in, 4 times 2 is 8, minus 9 is -1. And we see we have a pattern of +4. So I can continue that pattern. And since it's linear, it is going to add or subtract the same number. So I'd have 3, and then 7, and 11. And to work backwards then, I would just have to subtract 4. So we can say -13, -17, -21, -24, 25. All right, on the graph now, we would need to connect the points. So you want to plot these same points, but now connect them. Because we can have those decimal inputs. And again, I would connect them because I can have decimal inputs. All right, so what is the difference between a sequence and a function? Well, if we make a little t-chart here, All right, so a sequence, if you look at our graphs, the sequence has the discrete graph, meaning we cannot connect those points, where the function has the continuous graph, where we do connect the points. The reason these are discrete versus continuous is the sequence is discrete because the input must be a whole number. Remember, whole numbers start with 0 and are not decimals. So they're not negatives and not decimals. So that's why we don't connect them, because you can't have decimal term numbers or decimal inputs. The function is inputs can be all real numbers, so that's why we connect them. Another big difference is the notation. So remember, the input for a sequence is n. The output is t of n. For functions, the input is x, and the output is f of x. And so, if you think about our sequences we've done so far, they've all passed the vertical line test. Remember, the vertical line test is how we determine if something's a function. So in actuality, a sequence is a specific type of function. Mind blown. All right, so we're going to say a sequence is a type of function. So it's kind of like that whole every square is a rectangle, but not every rectangle is a square. Every sequence is a function, but not every function is a sequence.